Good morning. Today we're going to be connecting the model data of our project to the user interface and vice versa. So we're going to look at how we can actually make it so we can have an interaction between the user interface and what the user sees versus what we prepare in the middle side or the back end of our data in our op model package that the user has no idea how it works or functions. We're going to look at how we're going to make that happen. So as you can see right here, we're inside our Pokemon project. We're using that Pokemon inheritance project to make that analysis today. And if we take a look at the project structure over here on the left, as you can see in our controller package, we have our runner and our controller files. In our model package, we have our different interfaces and Pokemon types that we're working with. In our view package, we have the frame and panel classes. And inside the view package, we also have a folder for the images that we'll be using for that to provide the actual information for our interface. So I'm going to go ahead and take a run for this really quick so we can see what's happening inside the application. As you can see right here, we have our cute little application we're working with, so we can actually see what we're going to be working with to create this application. And so we have some fields the user can interact with up here in the actual text field area with the labels that go along with that. I can go ahead and click up here and I can choose my different options, and if the option is not available, it just gives me a default image because I don't have anything that I can show for that, so I can have that information right there. We also have inside here the ability to make changes to our object. I can update the Pokemon, and then I go back through it to look at something else, go back to that Drifloon, and now that's no longer available. You can see there's a change or interaction. I'm maintaining the state of my object and transmitting the information through that. Instead of Spooky Balloon, I'm going to change that to a Cute Balloon. Hit update the Pokemon right there. Go back, go to a different object right here. Choose the electrode. Go back to that Drifloon. It's a Cute Balloon. Go back to this electrode. It's a Cute Balloon, so we have that information right there, so we can make that update to our model state on there. It's available for us. We can have that happen. And so we have that information, we can actually load that information as we go through, and then we're having that interaction, we can maintain that state with that. So we can also save the changes for that, which we'll see in our other videos, so we can do and actually do a serializable set of information. But we're going to take first a look at how we can actually interact with the model itself and have that happen. To start off, we want to take a look at our controller package and our controller file. This is the one that does all the handing off work. This is the one that's in the go-between between our model information and our view information. So the model view controller relationship, the controller is the one that does all the passing information back and forth. It knows about both the model and the view. However, it doesn't get interacted with by the user. The user interacts with the view and like, oh, I can click on the buttons, I can scroll through the things, I can use that stuff because the user knows how to work with that. It has no idea this stuff exists or even that's there. We use this as a go-between so that way with the view itself, it can make any changes it wants to. It can then just call the appropriate methods inside the controller to have that happen. The controller knows about how to work with the model, and it can send the information to the model and tell it what to do as well. So we have that information right there. So let's take a look at the structure of the class, how it's put together, and we're going to go from there. We have in our import section, we have a couple imports we need to handle within this. So we have the import for array list because we have to handle our list of our objects because we're working with things. We have to have a list of them. So an array list is obviously imported. The JUp Champagne import handles it so we can have some reaction to the user in case of any problems or interactions we're working with on that. We then import everything from our model package because the controller owns the models. They're the ones that tell them what to do. It's kind of like the analogy, again, if you're working with an analogy of a movie theater, the director, they're the ones that tell the actors, the set managers, all that stuff, all the people who work with the props and everything, they tell them what to do because that's their job as the director, and they're like the controller of a program. They're the ones that tell everything else what to go, where to be, what lines to say, etc. And so that's the same job we have right here in the controller of our file. We then also have a reference to the Poke frame because it has to have a reference to the frame that can tell it what to do, and we'll see how that's set up right here. As we first look at the project, we can see we have some data members. We have that array list of Pokemon type, and so the Pokemon array list is an example of polymorphism in action because the abstract class Pokemon can hold any of the Pokemon we're putting in there. So any Pokemon type I want to put in, I can work with that and it's good to go. Our next data member we have is the Poke frame reference called appFrame, which is the window we're holding all of our application in. And notice again that I'm only holding the reference to the frame itself right here. I'm not holding any reference to, say, for example, the panel or the buttons or the individual GUI components we're working with. I just hold the window it's in charge of it because, again, the controller only controls what it has to. It then passes the delegation or what it needs to control on to the things that it's working with below that. And so that way the Poke frame can have the panel, it can work with that and do that information right there. And we'll take a look at that in just a bit. The first thing we want to take a look at is inside our constructor for the Poke controller. Again, when we're building our controller constructor, the first thing we want to make sure we handle is we take care of all of our model data objects. If we have any data we're taking care of, if we have any model objects we're working with, or anything that's structurally important, those all need to be initialized first before we even get to the view package. The model stuff has to be set first because we have to have the data for our app before we can talk about presenting it. So that's why I have the Pokemon list as a new array list of type Pokemon, where I initialize the list as an actual object so I can work with it. I then call the create Pokedex method. The create Pokedex method is where I'm working with the students, and we're going to make it so we're going to add a whole bunch of different Pokemon to it. As you can see right here, in the Pokemon list, we're calling the .add method, and I'm passing a bunch of Pokemon. A new Gengar, a new Drifloon called Spooky Balloon, a new Electrode that has a default constructor, and a new Drifloon passing the 2-parameter constructor, passing a number, I know it's wrong, and Balloon of Death. Dun, dun, dun. Yes. So we create a Pokedex like this. As you can see right here in the assignment, the students have to put at least 10 different Pokemon using all 3 of their constructors. We have an example of a couple of them right here because we want to have their application they can use and work with have a bunch of different options. And we'll take a look at that as we go through. Now, after I call my create Pokedex method, I initialize my app frame. So I'm going to put together my app frame, the frame that holds that. That's up here inside the PokeFrame class right here. You can see where my cursor is. But first, we're going to take a look at all the code that we have to work with to make the controller actually function and go behind the scenes and do the work we need. All the methods in the controller we're working with besides create Pokedex are public because the controller, again, is that go-between thing. It sends the information, receives the information. So the methods it's working with, because they're in different packages, have to all be public. So I'm going to go ahead and collapse out these things right here so they're out of the way because we don't need to look at that right now. And the methods we're going to take a look at first, we're going to start off with validateInt. We've done this method before when we're talking to actually validate the information from a user because we can't guarantee that a user is going to put the right kind of information in. And so the way we worked on that is we use a validator, and that validator belongs to the controller because it's the controller's job to handle that kind of information. It's not the view's job. It's the controller that makes that logical decision, then sends the information off to where it goes. So we have that method right here inside our controller class. The validateInt method takes a string parameter. It checks to see if it can possibly parse that to an int if possible. If it does, sweet, sets a value to be true. Otherwise, if that does not parse, it'll catch a number format exception, throws that exception, puts a pop-up on the screen, and then the user has to take care of that on their own. If it doesn't work, then we're good to go. That way, our app, in case the user types in the wrong kind of information, it's not going to crash our app. Instead, the exception is caught and handled so we can keep the app going. And so that's what the validateInt method does. With the updateCurrentPokemon method, it's a void type because it's not going to return anything back to the user or back to the panel it's working with this. Instead, it simply takes a string name, and int index as a parameter, and int health as a parameter, and evolve parameter. And it's going to say, hey, go to the Pokemon that's at this index, the one that I just selected right now, whoever I have selected, get that Pokemon, and I want to grab that out of the list using the get method. And hey, I want to change your name to this new name. I want to set your evolve to this new evolve value, and I want to set your health to this new health value, so I can properly update my Pokemon, so I can maintain the state of my objects inside my controller, that array list of Pokemon, and that's handled again through the power of polymorphism. Because even if this is a Gengar, when I take the Gengar out of the Pokemon list, it still has access to all the data members that belong to all the Pokemon, so I can update those values and work with them right here. And so that's what the updateCurrentPokemon method does. It works really well for maintaining that state. And so it's a public void method. It's basically just a big setter, so I can take all that information that the view can handle of strings, ints, and Boolean stuff from checkboxes, take all that information and send it off over here to the controller, so it doesn't have to worry about doing anything about Pokemon inside the view, because the view doesn't know what Pokemon are. It knows what strings are, it knows what pictures are, and it can handle that. So we make sure we try and abstract all that information away, pass it back to the controller so it can take care of the things that it knows about as well. Our getPokemon method right here is it returns a string array, and that's going to get all these names of the Pokemon that exist inside our project. So what we're going to do is we're going to create a string array called Pokemon names. It's a new string array that's as big as we have a list of Pokemon. So I'm going to go through and grab all the names of the Pokemon. The way I'm going to do that is I'm going to go use an index-based for loop or a standard for loop, start off at 0, go up to .size, and I'm going to go up by 1 each time. And each value inside my array, I'm going to put that as the value of PokemonList.get passing it the index, and then I'm going to use the method getClass. The getClass gives me the class information for it, and from that getClass method, I'm going to get the simple name, aka what kind of thing is inside the list. Is it a Gengar? Is it a Drifloon? Is it a Pikachu? Is it a Bulbasaur? Whatever kind of Pokemon I have, the model information, I'm going to extract that model data, and all I'm going to get out of it is the string name. Because again, when we're talking about the model-view control relationship, the view has no idea what the model is working with. However, it has a great idea of what strings are, because strings are easy. So I get that string out of there, and I put it inside the array called Pokemon names. Then I return that Pokemon names when it gets called, so I can have access to it, and we can go from there. The next method we have when we're working within our controller is the string array getDisplayData passing in an index. So the int index right there refers to the spot inside the array because we have to actually work within, the int index refers to the spot within the array list because I have to actually get the individual spot that I'm talking to inside that array list so I can work with it. So I say a string array data is a new string of size 4 because that's how much information to store. I'm going to go inside my Pokemon list at that index spot. I'm going to grab its name, its health, and its evolve status, and I'm going to put them inside the values of that string array, because again, remember, an array can only have one type of thing, and because I only have one type of thing, it's going to be used strings because it's the default value we're working with on all of it, so I can hold all the values in there, and because I can then, using the magic power of the append of a blank string, it automatically stores all the values with no extra information to it, so I can have it right there inside that. For my last value inside there, my string types is a blank string, and then I'm going to go through the Pokemon list variable. I'm going to go inside the Pokemon at that point and use its getTypes method to get all the implemented types, aka all the different type of Pokemon it has. And again, that's a string array. I'm going to grab that string array. I'm going to append the string into the string value right there. So types plus equals type plus a space. So I can get all different implemented interfaces that go along with that and store that inside right there and assign that to the fourth value inside the array. I then return that information so I can access that information and put it inside my display. So I have the ability to retrieve information and set information from that. As we go through this, we've actually taken a look at the controller class. The controller class is that go-between we use to actually have the information so I can interact with the model information that the view has no idea about, or even the user has no idea about. The user just like, oh, I've got this cool app, I can look at stuff. But the information is passed through and controlled by the controller, because that's how that go-between happens using the model view control relationship. So let's go take a look at our PokePanel, the one that's going to be doing the work on this, and see how that works. Now, in the PokePanel.java, we have a bunch of imports. You can see those right there. We don't need to go into a lot of detail with that because that's not what we're really working with right now. We have our user input fields that we're working with on this. The ones we're going to be taking a look at specifically today are the update button and the Pokemon dropdown, because that's what we're working with on that for the user interaction components. And as you can see, we have our evolvable box labels, fields, labels, etc. And we're going to be working on getting information out of those, but we don't need to go into a lot of detail with it. We also have an image icon data member right here, and that's really pretty easy. But where we want to take a look at the stuff that we're working with is we want to take a look at the constructor itself. And inside our constructor, we have right here with the initialization of all of our data members. And as you can see, we initialize every data member except for that image icon, because that's handled dynamically as we work within our project. But we have all those data members initialized right there. And you can also, at the bottom of the constructor, we have these 4 helper methods that are called right here. You can see them right there on the screen right now, of setupDropdown, setupPanel, setupLayout, and setupListeners. By having those helper methods called inside the constructor, we're able to have the farm out the work of doing all the configuration and the manipulation and stuff that set up the actual view itself in nice little easy repeatable methods we can call and use as needed. And so we're going to go ahead and take a look at those methods to see what we're doing inside them so we can see how they work and how they can be used to actually help send information back and forth. The first one we're going to take a look at is the setupDropdown method. The setupDropdown method is how we're going to set the dropdown combo box, or the J combo box, so we can actually have it have the information we're working with inside our app. Now, a J combo box has a type attached to it, and so our type is string because we're holding the strings inside that. And in order to link the J combo box to that, the way we do that is with what's called a default combo box model, which is also typed, and it should be the same type of thing we're putting inside there. In this case, it's again a string type, so that's what we're working with that. And so the Pokedex model is a new default combo box model of string, and then we pass it an array. The array of strings that we're working with is that controller's reference to the getPokemon method. So I go through and I get all the names of the Pokemon types that we have inside our list of Pokemon. I pass that as a parameter right here inside this. And because this is called inside the constructor, which the constructor is called by the constructor of the frame, which in turn is called by the constructor of the controller, that information is already currently initialized. So when we open our app, it already has validator right here. So we're passing it values we can work with and use. Always a good thing. Then I'm going to set the model to be that model I just created. So I initialize it and install it right there. I'm then going to tell me a Pokedex model label. Then I'm going to say I want your label, it's the text position, to go to the bottom of the label and put it in the center so it can have it look really nice. My last line is a call to our update helper. Our last line is a call to the updateDisplay helper method with a blank string, which will cause it to actually load some information. Then we'll take a look at that in just a bit. Our setupPanel method, just like all of our other setupPanel methods you've watched in my other videos, is just how I actually load all the components inside my layout. And so I'm using my Spring layout and I add all the pieces to that. As you can see, again, I keep them all together by groups so I can actually work with them really easily. Not a big deal, pretty easy to handle. My setup layout method, we don't need to worry about that at all because all it is the dumping ground code that holds the layout constraints. We don't have to worry about that. But we do want to take a look at our setupListeners method. And our setupListeners method is where I attach the listeners to the 2 components we're working with right now. In that case, the update button, the Pokemon dropdown. And we're going to use the standard approach of an action listener that we've used for all of our other buttons. The same thing as the same kind of listener we actually use when we're working with our J combo box. It's still just an action listener. The really nice thing about using that structure of the AWT action listener event is that the action listener works the same on almost every single GUI interaction component, and even if I'm using a text field, it's the same basic approach. I can handle that really easily. So when I'm using an update button, I have the click event is what I'm working with. When I have the click event, I call the updatePokemon helper method, passing it the index that I'm working with right now. So I ask which Pokemon I'm going to update. I'm going to grab that number that I have selected and go from there. The same occurrence happens when I call pokemonDropdown.addActionListener. At that time, for the action performed, I get the current Pokemon out of there by doing the selectItem.toString. So I grab whatever's valued inside that, grab the string of it, store it as a Pokemon. I tell my updateDisplay method to update the current Pokemon past that parameter. I then retrieve the data information from the controller's display data, passing again that select index. Which one am I clicked on right now? So I'm going to go, oh, that's the one I have clicked on. That's what I'm working with. Yay. And finally, I'm going to call updateFields and pass it that data array. So let's go ahead and take a look at those three methods we're using inside our action performed that we're calling from that, starting with updatePokemon. When I update a Pokemon, the first thing I want to do is I want to get some values on this. So I set my default value of health to 0 because it's a local variable and it has to have a value that starts off. I then have a string called health and a boolean called evolve. And then I check to see if I can validate that value that's inside the health field properly. Did they actually type in an integer value? If they did, great, I can update my health value. Otherwise, I have a default value of 0, so I don't have any lost information or corrupt information, and my app doesn't crash and burn. Because I'm using that helper method we just saw earlier of validateInt, and I can parse that int out there and get a correct value for it. I then initialize my name and evolve variables with the values that are associated with the values from the associated fields, aka name field get text, and evolvable box.isSelected. So those return to the string or boolean value appropriately. I then retrieve those values and I send them to the controller, passing it the send them to the controller by calling the updateCurrentPokemon method, passing it that name, the index I have selected, the health, and the evolve values, so I can go to the array list of Pokemon that's stored inside the controller object, which again the view has no idea about, just saying, hey, I'm going to give this information, do stuff with it. That way you can parse the information out and send it to the other person who's in charge of it, and they can do the job properly. So updatePokemon grabs the information the user has typed in, makes sure it's all good, and sends it off and updates the state of the internal objects. All good from there. So go ahead and close that out. Now we're going to go take a look at what we have for updateDisplay and updateFields. We'll start with the updateDisplay method first. So the updateDisplay method is how I'm going to actually update the view within my screen itself so I can show information when I change what I'm looking at. And so the updateDisplay takes a string parameter. I build a path to look inside my existing project. That's why I start with a slash. I look inside the package structure. So I go to the Poke folder, I go to the view folder, I go to the images folder, and then I append another slash at the end so I can go and look inside that folder as well. I have a default extension of ultraball.png so I can actually get a default file that I can work with. And what I'm going to try and do is I'm going to say, hey, Pokemon icon, I want to reinitialize your icon with a new icon, passing it getClass.getResource. I want to look inside my bin folder for the file I'm looking for. And inside my bin folder, do I have a file that's called, Gengar.png or SuperUltraPokemon.png? And then so I can see if that picture is in there. If it is, great. I reinitialize my image icon, and I'm good with that. If I don't have that file right there, if I have some random file that I couldn't find, or I couldn't find a picture of that Pokemon, then I'm going to catch that exception of a null pointer exception that would be thrown when I try to make that new image icon. And instead, I'm going to make a new picture, passing it the information I have supplied by default, in this case, the Ultra Ball PNG, which is already preloaded inside my file. So we're good to go and we can make that happen. And then I say Pokedex.label.setIcon. So I'm going to take that icon I just recreated right there, and I pass that as a parameter to that so I can have a new icon on that parameter. And again, we call this updateDisplay both right here inside the action performed of our dropdown, but we also called it when we first set up the dropdown listener, excuse me, we also called this when we first set up the dropdown at the beginning of the class. We have a default picture installed, and when I passed it blank, there's not a picture of blank.png. That doesn't exist. So I automatically put the Ultra Ball as my default image inside that. And then at the end of the method, I call repaint, which says, hey, frame, panel, reload yourself, make it look nice and pretty. And so that's what we do within that. So that's how the updateDisplay works. Finally, we have our updateFields method, which takes that string array of data. And that string array of data is a parameter. I go, okay, hey, here's that data. So name field, change your text to be what's inside the 0th position. Health field, change your value to be what's inside the 1st position. Evolve box, set your selected by parsing what's inside the 3rd slot. And finally, hey, types, grab the value from that that's inside to the 4th spot or data sub 3. So we grab all the information that's sent as a string array and we pass it to all the appropriate components, and it shows up right there on the screen. So that's how we can do that. So let's go ahead and let's take a quick little review of how that works in action one more time. So we have our program starting up right here at the beginning. As you can see, when I first started up, because I sent that string parameter of blank, it didn't load anything there. So I get the default Ultra Ball is the right one right here. And so nothing is stored right inside here because I haven't referred to any individual Pokemon. So I use my drop down on here so I could actually click on something. I'm going to go to my Drifloon. I'll go to my Electrode. Boom, here's my Electrode. Is this evolvable? Right now it's set for no, so I'm going to change that to be a yes. This Pokemon name, instead of Electrode, I want to have this be Cute Zappy Boy. And it has a health of, 3, 4, 5, 6, because that's another name. And I don't have any types in there because I implemented the information. I'm going to go ahead and update that current Pokemon. Boom. I'm going to go back up here. I'm going to go ahead and take a look at Gengar. There's my Gengar. It's a spooky boy, and it has a health of 100, and it's not evolvable. Oh, no. So let's take a look at that and go back to our cute little Electrode. And boom, I changed it. Look, the name is changed right here. The value is changed right here. I updated that information. It's all right there. It's amazing. I'm maintaining the state, and my pictures change by value. Really cool stuff. I go to my Drifloon right here. It's a Fire Ghost. It has evolvable, yes. It's called Spooky Balloon. Its health is 300 by default. It's called the Fire and Ghost is what it's implementing. I know it's not correct, but that's okay for the project. It's good. Go back to my Gengar, take a look at that, and back to Spooky Boy. I can set it to be evolvable. Now, if I just go and change this to, say, the Drifloon, it doesn't make a change. So I'll go back up here, and my Gengar is still back to not evolvable. But if I update the changes right here, instead of Spooky Boy, I say Spy Boy. Yes, it's Spy Boy. Go back up here, go to Drifloon, go back to Gengar. It's updated automatically, so it's now Spy Boy. So I can make those changes. That state is maintained. So again, as a quick review, let's take a look at what we did inside the code to make that happen so we can see what we're doing. All the code that makes the information change happens because of the controller. We send all the information to the controller rather than giving it Pokemon information to the actual view, because the view has no idea what Pokemon are. It knows what pictures are, it knows what text is, it knows what numbers are, it knows what checkbox are. It can handle all that. However, the logic and the model that goes inside the actual Pokemon class, all the stuff right inside here in the model package, it has no idea about any of that, and it doesn't need to know that information. And so the information that happens inside Pokemon.java, it doesn't need to know any of this stuff. It doesn't need to get access to any of that information, because that's information that's just for the model itself, and the controller can handle all that for the view itself. The controller knows about the model. The controller can handle the model, sends information to the instances of the model that it works with, and so it takes care of that on its side. The panel itself is where all the logic itself gets sent down to. We have some helper methods to load up our information and update the information. And again, when we're working with that information inside the panel handles just the raw data itself, so strings and primitive values, so it can upload that stuff. And then for pictures, it can take the pictures because it can upload an image from that. But that's how it does all the information for that. It doesn't worry about any of the actual logic of the model package. It just handles the view and it takes care of that. And that way the distribution of roles and the jobs that are handled by the code all work together in the best way possible. So this is, again, a way we can actually make sure we handle the idea of sending information from the view to the model and back and forth using the controllers that go between so we can have that updated. Thanks again and have a great day.